Welcome to this session, revision video on climate change. So this is the first part of this unit, which will come in your Unit 1 exam in the natural hazards section. So climate change is the result of natural and human factors and has a range of effects. So you could be asked about the natural causes, which are nothing to do with humans, or the human causes, which absolutely are. And that there are a range of effects, and this is quite generic, but you need to have some ideas. Okay, so let's just look at the evidence from the start of the Quaternary. So since the start of the Quaternary, what is the Quaternary? The Quaternary is a period of time. So since the start of the Quaternary, which is 2.6 million years ago, the climate has been changing. And the climate, if we drew a temperature graph like this, the graph would look something like this. So over 2.6 million years, the temperature on the Earth has fluctuated, gone up and down. Now, when it's at its lowest, and we can see that that's happened periodically through time during these fluctuations, these bits here, all of them are ice ages. And so when the global temperature was at its lowest, we've had a series of ice ages, and in between these we've had a series of these warm periods or interglacials. So essentially, over the last 2.6 million years, we've had an ice age, then it's warmed up as it is today. Ice age, warms up, ice age, warms up. And when there's an ice age, the ice at the poles has extended down through, in the northern hemisphere's case, across Europe. And then in between these ice ages, the ice retreats back. And this can be very, very clearly seen. So what is the evidence to show that this has happened? How do we know? Because you might say, well, you weren't there with a temperature, with a thermometer at the time. So if we have a look, one of the key pieces of evidence is ice cores. Now, if you went to Antarctica or to Greenland, you'll find that there are some very, very thick ice sheets. And the ice at the bottom is the oldest, obviously, and the ice at the top is the youngest, because as snow falls, it lands and it gets compacted down. Now, as that snow falls, as snowflakes, and I'm sure you've seen pictures of them or made little papery snowflakes in time, they have these arms, and as they compact down, bubbles of air get caught inside. So if we took an ice core, so what happens is scientists come along and they core down through the ice and take out these long cores and take them up, so they can access this very deep ice, which may be hundreds of thousands of years old. And within that ice core, they will find bubbles. And these bubbles are the atmosphere of the time, and they have been locked in. They're completely surrounded by ice. So if you can, under laboratory conditions, take out this this atmosphere within the bubble, if you can extract the gas, you can have a look at CO2 levels, and very cleverly, by looking at oxygen isotopes, you can also work out the temperature at the time. Now, it doesn't mean that the gas in there is the temperature at the time, but they can look at the oxygen isotopes. Don't worry too much about this, but there are different types of oxygen, and one will be heavier than the other. So if you've got more of the heavy oxygen, the oxygen 18, that shows that temperatures were higher because it caused the heavier oxygen to be up in the atmosphere. So all you need to know is that we can look back over hundreds of thousands of years using these ice cores and getting right down to bubbles of atmosphere at the time, hundreds of thousands of years ago. And that is a very important piece of evidence that shows us that the temperature has changed over time. Okay, there are other pieces of evidence, of course. So you can also say, for example, you had a lake You could go down to the bottom of the lake, and again, you can look in the mud that builds up. And again, you can actually use isotopes, oxygen isotopes that are held in maybe the seashells, again, to look at this. You can look at the changing shape of glaciers. So if you go into the mountains, glaciers are shrinking. Obviously, we have temperature readings from the last few hundred years, and so on. So there are lots of different things. If you look in a tree, if you cut down a tree, there's my little tree, and you'll know that it's full of tree rings. Now, if those tree rings are very narrow on one particularly in 1 year, it shows that maybe the growing conditions weren't great. Maybe it was colder. If they're very wide, maybe the growing conditions, it was warmer and the tree was able to grow more. Now, having lots of different types of evidence is very important. Have a think about why you might want to have lots of different bits of evidence. Okay, well, the key thing is, if you can look at different evidence and say, for example, we have some tree ring data that tells us that the temperature's done this, and then we have some ice core data that tells us, according to that ice core data, that the temperature has done this, and then we have some actual recent readings that suggest that the temperature has done this, then we can be fairly confident because they're telling us the same thing. If you've got 3 pieces of evidence giving the same information and one that's not, maybe we can discount that, or we'll have to look at it and try and work it out. But the more different types of evidence, the better, because it will basically back up the other evidence, and it helps us to be sure that we're looking at the right thing. Okay, so why? So if we look at this, let's have a think about why temperature might have gone up and down for natural reasons, nothing to do with humans. So this has been going on long before humans started burning any fossil fuels. So what's been going on? There are 3 reasons that you need to think about. So if we put down natural causes of climate change, and probably the most important is this: orbital changes. Okay, so you're probably very, very aware that you are currently spinning through space around the sun. Let's make a little green planet Earth. So there we are. And at the moment, the orbit of the Earth around the sun is quite circular. Okay, so we're going around the sun in this kind of an orbit. We go once every year around the sun, and we're currently spinning as we go, making our days and nights. And that 365-day orbit gives us our year. But the fact that we've got a circular orbit means we're always about the same distance away from the sun. And that means that we are currently in a warm period or an interglacial. That's why we're not currently having an ice age. Now I'm going to exaggerate the next one, but because of gravitational effects from other planets in the solar system and so on, at certain times our orbit changes, and it changes from one to the other. So sometimes our orbit is more elliptical, and when our orbit is more elliptical orbit, I shall put down there. When it's more elliptical, we have an ice age. And that's because while we are closer to the sun at certain times of year, we're further away. And that means that it's cooler, and that the ice at the poles is less likely to melt, and therefore builds up, and we get ourselves an ice age. Okay, so round orbit, warm period; elliptical orbit, cooler, ice age. Now there are 2 other things going on with the Earth. Number 1 is that we are spinning at an angle. So if you imagine that's the Earth and it's spinning around this orbit, and that's sort of up near the North Pole and down near the South Pole. We're actually at a bit of an angle. That's what gives us our seasons. But that angle can change slightly through time. And in addition to that, there's a kind of a wobble on that orbit. Now, the thing I want you to take away from that is that at times this tilt, in addition to this elliptical orbit, means that, again, these poles receive less energy from the sun. And again, that's more likely to lead to an ice age. So the elliptical orbit, leave it at that if you like. If you'd like to add in this effect of the tilt of the Earth changes slightly, adding to this cooler effect, then that's great. And together, this creates a Milankovitch cycle. And that explains quite nicely why at certain times we have an ice age, because we've got an elliptical orbit and the tilt is having that impact. And at the other times, as we are now, we have a warm period. We have a circular orbit. Okay, so that's number one. And that's the main driver for this cycle of ice ages and warm periods through the Quaternary. Two others you might like to think about. Number two is sunspots. So the sun does get spots, and those spots appear as dark areas on the sun's surface, and they give out more heat. So when there are more sunspots, and this is to do with the inner chemistry of the sun, they actually give out more heat. Basically, temperatures increase on Earth. Now, if, happy days, we looked at the sunspot activity right now and said, my goodness, over the last 150 years, there's been a lot more sunspot activity, that could happily explain away our current temperature rise. Sadly, that is not the case. So that can't explain what we're currently seeing. The third one is volcanic activity. Now, volcanic activity, if you think, when a volcano erupts, not just a volcano being there, we need to have an eruption, it can send large amounts of ash up into the atmosphere and dust. And that dust, obviously the heavier particles will fall out, making the soil more fertile, impacting humans and environments. But some of the lighter dust can get up into the upper atmosphere and travel around the world. And it can actually, this dust blocks sun. And that can lead to lower temperatures. Okay, so these two here are short term. In the short term, over years, or we can have more sunspots and temperatures increase. Again, over years, we can have massive volcanic eruptions, and this can put dust up into the atmosphere, and this can block out the sun, leading to lower temperatures. There can also be more greenhouse gases, but I'll just stick here with dust. You may want to read further on that one. These are all natural causes of climate change, all of them. So this is nothing to do with humans. And if your exam question asks you about natural causes of climate change, these are the ones you want to be talking about.